Hello everyone. I am going to show you how to graph polynomials by using end behavior and x-intercepts. So they're just going to be sketches. They're not going to be exactly precise. So the very first thing with problem number 1 is to notice where it would equal 0. So what I would do for that is set each factor equal to 0. So I would say like x minus 1 equals 0. You can probably do this part in your head too. X plus 3 equals 0 and x minus 4 equals 0. So this first one would give me x equals 1. Then I would get right here x equals negative 3. And this would be x equals 4. And I'm sure you've probably been seeing this in other stuff that you've done. It's always the opposite number of what's inside of the parentheses. So those numbers are the x-intercepts. They're also called zeros or roots. So x-intercepts slash zeros slash roots. Those are all just different names to talk about the same thing. So I'm going to plot on here at positive 1, an x-intercept right there, at negative 3, an x-intercept, and at positive 4, an x-intercept. Now, the next thing that I look at is the leading coefficient. That's a negative 2. So if the leading coefficient, I'm going to abbreviate there, is negative, what that tells me, look down at the graph here, is that the very end of my graph will end downward. So if the leading coefficient is negative, then the end of my graph is going to go downward, like that. So it just gives me a little bit of a heads up and tells me where to start. I usually draw these backwards because I know the end behavior of that right edge. So then the one last thing to notice before we start drawing the curve is that this x minus 4 was squared. What that means is that at 4, it will bounce. The graph will bounce. So here's what's going to happen. I'm going to start drawing from that arrow that I already drew. Now here I'm getting close to 4. A bounce means it's going to go like that. If it didn't bounce, it would go through. But we're not going to go through. So it bounced. Now, it doesn't matter how low you go right here. Like if I curve, I need to come back around to this point. But I could go lower and come back around to that point. That really doesn't matter. That's why this is a sketch. So I'm going to go curving back around. Now when I get to 1, it's not a bounce or anything. So I just go right through it. And I can go as high as I want, but I do need to come back and go through this other x-intercept that I drew. It's kind of like connecting the dots. You just have to be careful of bounces. And this is the whole function. Now one last thing you can double check to see if you did it right is the degree of everything. See, x minus 1 was to the first power, if you look at the equation, and x plus 3 was to the first power because there was nothing written there. So if I highlight all of the exponents, they add up. 1 plus 1 plus 2 adds up to a total of 4. So it's an even degree of 4, which means that both edges should go the same direction. So this is kind of just a way to double check your sketch, and it looks good because this edge, this is what I mean by the edges, those two yellow parts, they are both headed downward. So that makes sense. I'll just put a check mark there. And so that's the sketch of number 1. Now problem number 2 over here, we will start it off the same way. So I'll just make a little list. I'm going to do this part in my head this time. The x-intercepts are x equals -2, x equals 1, and x equals 5. So I start a graph. And I plot those. -2, +1, right there, and +5 is over there. All right, so I've got that. Now I'm going to notice my leading coefficient. It's a 6. The leading coefficient is positive. So what that tells me is that the very ending part of my graph will end up. So it's going to go up like that. Now also, if you look at the exponents, there is this 3 right here. That's a triple root. What that means is that at -2, it will flatten. And I'll show you how that will look. What I usually do for that is I go straight to -2, and I draw myself a tiny little flat line segment. And then I work that in when I'm drawing the graph. I still draw it backwards though, because I know that the very end of it was that up arrow. So I'm now going to draw this backwards. I'm going to pass through my x-intercepts and just like weave around. And now I'm coming back down to this one where it's flat. So I need to take my curve and I need to feed into that little line segment like that. And then I need to take the curve and it needs to feed out of that line segment. So right at -2, it has that little wobble in the graph, or the flattening. And if we double check the edges, let's add up the total degree of this one like we did last time. X minus 1 had a degree of 1 because nothing was written. Same with x minus 5. So if I highlight all of the exponents, I have a 3, a 1, and a 1. So the degree is equal to 3 plus 1 plus 1, which is 5, which is an odd number. So that means that the edges should go in opposite directions. So if we double check, it looks good because this edge is heading downward and this edge is heading upward. So it's doing exactly what it should have. So this is just the couple of steps you need to go through to draw a sketch of the higher degree polynomials like these 2 examples.